As you guys know, I will be away the next few days, so we're going to work on word problems. So we're going to work on some of these word problems here. And we'll do word problems for like 3 days, and then I'll be back on Thursday, and I can go over whatever you don't understand. What you need today is a calculator. Okay, so now I'll try to put it somewhere where you can see me type things in, and paper, and this handout. So whoever the teacher is there, can you make sure everyone has the handout? They can all take their calculators, and there is some paper in the front if they're missing paper. There's some paper in the front, but they need some paper to do the questions. The way I design these questions is I do a question, like I'll do this one, and the one that I assign for homework is very similar. I just took and put different numbers up here, but I did the same question, so it corresponds to the homework questions. So if we get through 4, I think you got 5 homework questions, then you should be able to do the 5 homework questions by just following along with these ones, just changing the numbers. Okay, so let's first start off what projectile motion is. So hopefully everyone's got. You can pause the video if everyone doesn't have what they need. They need the paper first. So let's start off. Okay, usually there's an equation for projectile, and I'll give it to you, a projectile motion equation. And it usually gives you the height, so h at t, and it's sometimes written differently. It starts off at minus 5. It's 4.9, but they round to minus 5t squared. And they put a velocity here, something like, I don't know, 20t, and then a starting height here of maybe 30. So I just made up an equation that'll give you the equation. So the equation will be given. Okay, so something like this. So it's minus 5t plus 20t plus 30. If you were to graph this, so let's make that a little clearer, the 30. If you were to graph this, so I'll set up, it'd be this type of graph. Time would go over here. Usually it's in seconds, but it could be in anything. And on the side, it'd be height. Now, none of these questions require graphing, but I'll show you how it would look in the graph version. You would start off here somewhere. There'd be a starting height, which would be the 30. So this starting height would be 30. This would go up, 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 and then come down slow like that, like a parabola or a quadratic. The starting height is the 30. The last number is the starting height. So this is where it starts, the start height. It's when time equals 0. When time equals 0. So you can always put 0 in for here. Here cancels those out. So it's the starting height. Here, the top part here, the maximum height. And how do you do that? Well, to find the maximum height, I just wrote max height, or the largest. Well, you find the vertex. And you'd have to complete the square, and we'll do some examples. And I'm going to complete the square. So when it says max height, the first thing, whoops, let's write complete the square a little nicer. You have to do is complete the square. Here's where it hits the ground. This is the time it takes to hit the ground. Hits ground. Basically, for this one, you just make the whole equation. So let's see. You make the whole equation plus 20t plus 30 equal to 0. And then you use the quadratic formula. So you use t equals plus minus, whoops, I forgot the first number in the front, negative b. I'm not going to write the whole thing. We'll do some examples later. Negative b plus minus the square root of b squared minus 4ac all over 2a. So it's a negative b, that equation. So what do you have to know for this unit? Pretty much you have to know this, how to use this formula and how to complete the square. And most for problems, that's all you have to do. Now, occasionally, it'll ask you at a different height. So say at this height, at what time is the ball or whatever at this height over here? So occasionally here, and it'll give you the height. And it'll give you this height here. So in this case, so let's say it gives you a height of, I don't know, 50 or something here. In this case, you'd go 50 equals minus 5t squared plus 20t plus 30. You'd rearrange it and still use this equation here. Okay, still you after you make it equal to 0, you'll bring the 50 over and make it. So I'll leave that. If someone wants to pause it, you can. You can pause it, and we're going to go to the second video. We'll do some questions. Again, we're going to maximum height, complete the square. Hit the ground, make it equal 0, use the formula. Starting height is going to be the number at the end. And in case we have to find a different height somewhere, random height, we're going to make the 50 equal that random height, bring the 50 over, and calculate. Again, if anyone wants to copy that, you can. I just did an example. And if you need a different time, you just sub in a different time. If you needed something at a different time, you sub it in. So I'm going to now, you can play the next video. You can pause it if you want, play the next video in a minute or so.